Let's get started today talking about polygons. First off, let's define some things. A polygon, let's define that. It's a closed plane figure. It means two-dimensional, basically, is what plane means. It's a closed plane figures with straight sides. They have the same number of sides as they do angles. Same number of sides as angles. Okay. Now let's list off some different types of polygons. Some of these you've probably heard of before, and maybe some of them you haven't. A triangle, which of course has 3 sides, that's a polygon. A quadrilateral, which includes things like rhombuses and, or is it rhombi or rhombuses? Rectangles, squares, parallelograms. There's a pentagon. We know that has 5 sides. A hexagon is a 6-sided figure. A heptagon is a 7-sided figure. And an octagon is an 8-sided figure. There's more. How about a nonagon? It's a 9-sided figure. A decagon is a 10-sided figure. Now is where we're probably really getting into stuff you've never heard of before. A hendecagon is an 11-sided polygon, and a dodecagon is a 12-sided figure. That's fun to say. Go ahead and say it out loud. Say it loud enough that your parents can hear it. A dodecagon. And then anything over a 12-sided figure, we'll just call it an n-gon. Well, we won't call it an n-gon. We'll call it a 13-gon or a 14-gon or a 15-gon or a 20-gon. Okay? Moving on. Name this polygon. Is it regular or irregular? And let's first start off by naming it. It is, well, I lied to you. First off, we're going to define whether it's regular or irregular. This is irregular because not all of its sides are the same length. Not all of its sides are the same length. We're just basing it off of looks in this case because they don't give us any dimensions, but it looks as though it's irregular because this side right here looks longer than these sides over here. And it is a hexagon because it is a 6-sided figure. 1, 2, 3, 4, 5, 6. So it's irregular because its sides are not congruent. And it's a hexagon because it's got 6 sides. Which of the following is not a way to name this rectangular? So not a way to name this rectangle. Okay, well, ABCD, let's check that one in green. ABCD, okay, that is an okay way to name this rectangle. You can start with any vertex you want and then go in either direction that you want, but you have to hit each vertex in order. So that one's all right, ABCD. Let's try ADCB, and we're going to do that in blue. ADCB. Yep, we hit them all right in order. What about BACD? BACD. See the issue there? We don't want that Z, okay? We'll check BADC just to make sure in black here. BADC. They're all in order. So looks like BACD is the one, and because it doesn't hit all the vertices in the right order. What is the name for the shape of a stop sign? You guys should know what a stop sign looks like. Looks like that, I guess. It is in 1, 2, 3, 4, 5, 6, 7, 8-sided figure. So we would call it an octagon. Pretty sure it's a regular figure that all the sides are the same length, but I'm not quite certain without having looked at it. The block H shown is a polygon. Count the sides and name the polygon. It's definitely a polygon. It's got the same number of angles as it does sides, and all of its sides are straight. So let's count the sides and let's name it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A 12-sided figure is a dodecagon. Use 4 letters to correctly name the figure that looks like a square. Start the name with the letter A. Well, the one that looks like a square is it's going to be this guy right here. Okay, so if we're going to name that, starting with A, we could go A, B, E, F. Got to put that little symbol out there, rectangle A, B, E, F. Or you could name it A, F, E, B. Either one of those would be fine. Which triangle appears to be a dilation of triangle ABC? Well, a dilation is simply a shrinking or enlarging of an object. You're not moving it, you're not spinning it, you're not flipping it. It's just changing the size of it, but its proportions remain the same. So its angles remain the same. So yeah, the answer here is probably pretty obvious after I give you that definition. Option A. Okay, you can see it's just about the same triangle, but it's shrunk down. Whereas B, it's flipped over. Okay, that's not called a dilation. And C is just a completely different rectangle. It's got different angles. So A is a dilation. And lastly, which figures below appear to be similar and which appear to be congruent? Okay, so the definition of similar is that they are in the same proportion. Their angles are the same measure. That's the bottom line. Their angles are the same measure. And the ratio of their sides are equal to one another. So let's just go off of looks for right now. I'm saying that A, B, and D appear to be similar. They have congruent angles. Okay, it doesn't matter that A is smaller than B and D, and it doesn't matter that B and D are flipped from one another or that A is rotated. They all have similar or congruent angles. Whereas C is, a trapezoid as opposed to these parallelograms. So those are the ones that are similar. Moving on from there, we'd say that B and D appear to be congruent. And the reason these appear to be congruent is because not only are their angles congruent, they have congruent angles, but their sides are congruent as well. Congruent sides and congruent angles. Okay, it doesn't matter that one's flipped from the other. Okay, if I flip object B, you can see it's identical. Okay, so that's what makes it congruent. All right, that's it for today. Introduction to polygons. Got some names you probably need to get down, but we'll get that down over time by doing the problem sets. And I'll see you tomorrow.